This is Women in Linux. Welcome to the Women in Linux podcast, exposing women to information and careers in technology.
Welcome to Women in Linux. This is Tamika Reed and Dion Parler. Last week, we spoke with an old friend of mine and actually my old manager at University of Washington. Her name is Emily Bender, and she is a part of the Computational Linguistics Department over at University of Washington.
So it's finally nice meeting you. I heard so much about you. I am looking forward to hearing more about computational linguistics from one of the masters, the greats.
Thank you so much.
Tamika's had so many good things to share about you, so I've been excited about the interview.
Well, thanks. And Tamika played a great role in getting our program off to a good start. So it's a real pleasure to talk with you guys.
Awesome.
And Dion, nice to meet you. So I guess I should introduce myself and then talk about the program and talk about the field. I am a professor in the Department of Linguistics at the University of Washington, where I've been since 2003. Prior to that, I was mostly in the Bay Area, where I did degrees in linguistics at UC Berkeley and then Stanford University, and worked for a little bit in industry at a startup called YY Technologies, which was a startup working in the area of computational linguistics. Computational linguistics is the field that looks at getting computers to deal with human languages, and that can be done for either the purposes of doing research in linguistics, which itself is basically the science of language or the study of how language works, or, as you might be more interested in, it can be done for practical applications. And those practical applications include pretty much any time you've got people using language, either spoken or written, in such a way that it is captured and digitized, there is probably an application for computational linguistics. So things like search engines and predictive text in text messaging and information extraction from electronic medical records. So there's a group at the Fred Hutchinson Cancer Research Center in Seattle, as well as other groups around the country that are looking at doing computational linguistics, or sometimes called natural language processing, over all of the electronic medical records they have of all of their cancer patients, with the idea that if they can pull the information out and the doctors can do epidemiological studies, then you got someone new coming through the door. They can be matched to the people who are most like them and therefore be given the most successful cancer treatment in their scenario. So lots of really interesting and exciting applications. There's also intelligence applications and legal applications, customer-facing, but also business-to-business. Sentiment analysis is companies looking at how people feel about their products based on what they're saying about them on Twitter, for example, automatically processing all that language. So all of that is computational linguistics. Adjacent to computational linguistics, sometimes included in it, is speech processing. So all of the problems that come up when you're trying to deal with spoken language. And that includes things like voice dialogue systems like you have with Siri or the Amazon Echo, where you can actually talk to a computer and have it be somewhat helpful these days.
That's a good one. Somewhat helpful.
So one way of answering the question of what is computational linguistics that I used to use is, say, remember the movie 2001 where there was that computer called HAL that you could talk to and it could answer you and be, in its own way, somewhat useful. Every single thing you would have to do there to deal with the language is computational linguistics. So going from the speech sounds to a written representation to an analysis of the structure of what was said, to an analysis of the meaning of what was said, to a sense of how that meaning relates to the current discourse context. All of that is computational linguistics. And then there's some non-computational linguistics AI in terms of deciding what to say back. And then once the computer has decided what to say, figuring out how to say it, and then actually turning that into words and then sounds is, again, computational linguistics. And so I used to have to point to the movie 2001 or to Star Trek to get the example, but now we can actually talk about Siri or Amazon Echo and people that have more experience with the technology themselves. You guys have any questions about that?
I'm like in awe right now because it's so vast. It's so vast, and how you brought it from that movie 2001 all the way to now, how the technology has grown.
Yeah, it is a huge field, but part of what makes it a tractable thing to work on as one field is that across all of these different applications, there's problems that come back over and over and over again. So taking a sentence of English and finding the structure of it, pulling out of it who did what to whom, is going to have to happen no matter what application you're doing with the language. Right. So there's applications across all these huge range of fields, but it makes sense to actually study computational linguistics as one thing and then apply it in all these different ways. And that's sort of what we're doing at the University of Washington. So we have a program called CLMS. Back in Tamika's day, we were CLMA because we're a linguistics department. And so we thought, well, we offer a Master of Arts. But we discovered that though our students have been very successful in getting jobs, it was a little bit of a hurdle to have MA instead of MS on their resume. And we looked into it and we said, you know what, this is a technical degree and there's no reason that it shouldn't be considered a Master of Science. So we petitioned the university to get the name changed. The curriculum didn't change, but the designation did. So now it's CLMS, stands for Computational Linguistics Master of Science. And that is a one-year program, if done full-time, so 12 months, where students do 3/4 of coursework, 3 courses per term. They're super intense courses. And then in the summer, at the end of that, they cap it off with either an internship or a project or a master's thesis. So it's possible to finish in 12 months. It's also possible to spread it out over 2 or 3 years. We have some students who spread it out because they're just not in a rush. We have some students who spread it out because they're working full time and taking classes on top of that. And we have some students who spread it out because they come to us with more of a linguistics background and less of a computer science background. So they need some more time to get some of those computer science prereqs in. And so it's got some real nice flexibility. And on top of that, we have what are called hybrid blended online in-person courses. So it's one of the same class. You can be there in the classroom or you can tune in online. We use Adobe Connect, although I'm constantly on the lookout for a better piece of software. And the distance students can watch live and send in questions via the chat box. They can also watch the recordings afterwards, as can any student who's there in a classroom or not. And we made that transition starting in 2007. We started using the software, and it turns out it was actually really easy to take a program online like that, because aside from the lectures, everything else was already computer mediated. So we have a server cluster that the students all use for their assignments and their research. That you guys know what server clusters are like, super noisy. In fact, Tamika used to maintain the server cluster for us. Tamika, you'll be happy to hear that it now lives in the UW Central server co-location facility instead of a closet in our department with a sort of jury-rigged AC system where you have to empty buckets of water. Those days are past.
Yes. Of course, yes.
So it's in the co-location facility that they have now. And so nobody is sitting right at the server cluster, right? Everybody's accessing it remotely, whether you're in Seattle or I've had students take classes from, and I'm not kidding, Argentina, Japan, India, and Azerbaijan.
Wow. Wow.
Yeah. So that's already all online. We answer student questions primarily through online bulletin board systems. It's called Catalyst. That's the University of Washington software for that. Students turn in their assignments online. So the only thing needed to actually make it an online degree program was the ability to have the lectures online. And with Adobe Connect, we can do that.
Wow. Now you mentioned that the undergraduate degree people move forward with are usually computer engineering or linguistics. Are there other degree programs that can build upon computational linguistics as a master's?
Sure. So computational linguistics as a field draws on computer science and linguistics and also probability and statistics. Mm-hmm. And so we advise people to have a background across all three of those before they come to us, but that doesn't mean they have to have a degree in that. Okay. And some particularly great sort of other degrees to come in with are, well, it depends on what you want to do with the computational linguistics, right? So there's applications in finance where people are using natural language processing over either sort of Twitter or SEC filings to predict what the stock market's going to do. So if someone's got a degree in economics would be well positioned to do that once they've also studied computational linguistics. Someone who wants to go into biomedical informatics, doing things like what I was describing with the Cancer Center, an undergrad degree in biology or health sciences would be a great pairing. So it really, hardly anybody knows what linguistics is before they get to college, or maybe even in college. And there's plenty of people who might be interested in computer science, but they don't feel like they fit in computer science, and so they don't do it, right? So computational linguistics is a sort of field that is a great way into these technical areas and can take advantage of whatever expertise you've built up.
Yeah, and it also sounds like it'd be great for somebody that speaks multiple languages.
Yes, absolutely. Because there's more than just English out there, and a lot of companies doing computational linguistics are really interested in moving into other markets around the world. And there's lots and lots of languages spoken by many, many people that do not have very much in the way of computational linguistic technology built for them yet. So my favorite example of that is Malayalam, which is a language of southern India. It has something like 50 million native speakers, I think.
Wow.
But you probably haven't heard of it because it's not typically taught at universities in the US, right?
No. No, we don't get that. That's not an option.
Yeah.
But no. We're going to get Spanish. And some French.
Yeah.
But no, we're not getting that language at all. No.
Yeah. But, that's a lot of people, and they could all, benefit from computational linguistic technology. And, they're using their cell phones to text, and they're searching through newspapers, and they're tweeting about products. And so for all these reasons, it'd be nice to be able to do natural language processing of Malayalam like we do it for English. Same for many, many other languages.
So I know you talked about getting, how you got your start in the field, but getting your start in the field, what was your draw? Like you were sitting in class and you said, hey, I want to do computational linguistics, or I just want to do linguistics. What was the draw for you?
So I didn't know what linguistics was until I got to college. And then in my second semester, I took the class was called Introduction to Language. And I took it just sort of as an elective because it looked interesting. And I knew from the first lecture that was my field. And that was linguistics generally, right? I took a little bit of computer science, like one computer science class as an undergrad. Learned to program in Scheme, which is a dialect of Lisp. And then in grad school, I went to grad school in linguistics, and I got involved in a project called LinGO, which stands for Linguistic Grammars Online, as a research assistant. And I really enjoyed that work, but I was doing my dissertation in subfields of linguistics that are not actually computational linguistics. I was working in subfields called syntax and sociolinguistics. And when I finished, I went on the job market trying to find a tenure track position in one of those subfields, and didn't turn one up. So I worked for a while at a startup building a computer grammar for Japanese that was meant to be used in applications involving automatic customer service email response, where the English grammar that I had worked on as an RA was already being used to do this in English, and they had some Japanese clients, so we were building up a grammar for Japanese to do that. And so that got me into the more computational side of things, and then when the University of Washington was hiring in computational linguistics, I was very fortunate to get this position.
I had just got there when you got there, maybe like a year or two, right?
When exactly were you there?
Probably 2003, 2000, maybe 2006, 2005, 2006.
So I started at UW in 2003, and the master's program started in 2005. I think you weren't there right at the very beginning of the program, but pretty quickly after it started.
Well, that's about right. So now, I know you mentioned earlier some of the your students move on to other companies and internships, but what companies do they normally move into?
Right. I could look that up in detail for you, but off the top of my head, we have students at Microsoft, Amazon, Google. Don't know that we've gotten anyone to Facebook yet, but that's certainly a possibility. Nuance, which is a very large company, especially in the speech technology space. IBM, a couple of folks working on the IBM Watson team. If you guys remember Watson that beat Ken Jennings at Jeopardy. which was sort of a stunt, right? But they were building that technology to actually work in, I think, decision support for doctors. That's the main thing that they're aiming at. We've got people who go to various startups, and we've got people who go on to PhD programs. If you want sort of the full details of the companies, I have a database where I track where everyone ends up. But it's sort of a broad range of companies, mostly in the U.S. because our students are mostly in the U.S. And we also maintain a jobs database where anytime I see a posting come through that looks like something that one of our students could do, I add it to the database. And I can send you that link if you're interested.
Of course.
And then, as far as the PhD program, what PhD program would you go into after that? Or is it depending on what you're studying? And in the master's program, like if you're studying like economics and then you roll into computational linguistics from a math background, what would be the next step if you went to a master's program? To a PhD program.
So most folks who go on from our program to a PhD program actually stay in computational linguistics, and they're either in a computer science department or a linguistics department. So some stay with us. We've had students go to Dublin City University and Aberdeen, and the one who went to Aberdeen then did a postdoc, I think, at Johns Hopkins, and now is a researcher at Microsoft Research. And I've had, I think I can think of only one student who went on to a PhD that wasn't linguistics or computer science, and she went into, I think it was speech pathology.
Okay. And so I know you mentioned earlier the skill sets that you want some of your students to have. So a reiteration on that would be your math, and I'm assuming probability and statistics, some language background, I'm assuming, and then what was the third one that you wanted? Or computer science, I guess. It should be that. And when you say computer science, are you talking just from a programming perspective, like, hey, understand how to program in Java or in C++ or Python or something of that nature?
Yeah, so for programming, in order to be admitted to the program, we need people to show basically aptitude for computer programming. But to take the core sequence in computational linguistics, they need to be proficient in one of Java, C++, C#, and then one of Python or Perl. And when I've got people asking me, okay, I'm just getting started now, what languages should I learn? I say Java and Python, because those seem to be the most widely applicable, especially on the Java side. And then Python over Perl, because it's nice to be able to go back and read your own code the next week. Speaking as someone who used to code in Perl.
Yes, I would agree with that Perl statement, and I also would agree with Java and Python, because I was looking at some books today with NumPy and SciPy and PyLab and looking at regression and linear algebra. So I can see how Java can kind of translate and Python can kind of translate over that. I would wonder how does Ruby play into that, like Ruby on Rails? How does that play into that?
We have a couple people who use Ruby, and the way our classes are structured, for the most part, you can go ahead and use whatever language you want, so it doesn't matter so much. Ruby has not proven to be terribly popular among our students, and I'm not quite sure if that's just it's not quite as widely used out in the world, or if it's just because we say Python, so people do Python. But there's some great resources. There's something called the Natural Language Toolkit, NLTK, which is written in Python, and a bunch of other sort of support for computational linguistics already. So
okay.
I know some people who use Ruby, but so we tell people programming, but also an understanding of data structures and algorithms, because when you're doing computational linguistics, you're very quickly dealing with a lot of data. And so if you don't know how to write things to manage memory in an effective way, it can take, it's just can become impossible to actually do the computation, or it can take way, way too long, right? So we recommend people do data structures and algorithms, and then they need to know something about linguistics. Now, we don't require as much of a prereq in linguistics because we are a linguistics department, but we want people to know what they're getting into. So we either say, take an intro to linguistics course or read an intro linguistics textbook, so you have a sense of what it is that field is and how linguists think about language. And we, a few years ago, put together a web page, a subpage on our webpage for the program. So the webpage for the program is compling.uw.edu. And under the admissions tab, there's something called preparing for the program, where we just put together some advice of what exactly you want to get, because it's not like you have to have, a double major in computer science and linguistics to do this. So like, what do you actually need, and how do you get it if you're currently an undergraduate where you have a chance to take some further classes, maybe outside your major, and how do you get it if you've already graduated and you want to come into this field? So we have that on a webpage, and it was interesting. It took about 2 years from when we put that on our webpage, but then we started seeing that the people applying to the program had looked at the webpage and followed our instructions, and we started getting a much higher proportion of really well-qualified applicants. So that was exciting to see.
Are you guys still in the same building?
We moved. I don't know if you remember where the fountain is, Guggenheim Fountain? No, Drumheller Fountain, Guggenheim Hall.
Okay.
We're on one of the buildings near there, and it's quite nice.
I bet you it is compared to where you were.
Yeah. Doesn't have the pretty view, but otherwise it's much, much nicer.
All right. And so I've been looking at deep learning, and I guess my question would be is, how do the two correlate, deep learning versus computational linguistics? Like how do they correlate, if they correlate at all?
So absolutely. So the very short version of the story is that all of the major conferences in computational linguistics are really heavy on the deep learning this year. It's like most of the papers are applying deep learning techniques. You can sort of think of computational linguistics as both a set of techniques and a set of problems. And those problems can be approached in purely symbolic terms, where you have computational linguists writing rules that capture the linguistic structures and then algorithms that apply those rules. Or they can be approached in stochastic machine learning terms. And once you're in that space, then deep learning makes a lot of sense. So people are really excited these days about neural nets, and you get buzzwords like long short-term memory. And at the end of the day, it's the same problems with the same way of evaluating success for the systems being approached with these new learning techniques. And my own personal feeling about this is that you really need both a linguistic understanding of what the structures are in language and a sense of the probabilistic approaches to it, because while some of the things are amenable to linguists writing down rules, some of them really aren't, and you want to get that sort of throw a bunch of data at the machine and have it pull the information out. But even if you're just throwing a bunch of data at the machine, it really matters how you represent the data when you're giving it to the machine. So if you just give the machine... So
putting the data together, so I was reading like you have to kind of like massage the data, like, to get it to a nice set, so you get the accurate information, because you don't want your data set to be like everything is in the middle and then you got 5 data points off to the right, and so that considered an anomaly, and then you have to kind of explain that anomaly.
Right. So there's definitely effects like that. There's also things like the data that we're working with is going to be, setting aside speech, is going to be text data, right? So do you just give the computer a stream of characters? At that point, you're losing a lot of information, right? Although there actually is some work with the deep learning that looks at language as strings of characters. If you're going to say, okay, well, I'm going to look at words, then you have the problem of identifying words in the text. In English, that's mostly not a problem, although if you think about the way people use hashtags, it's non-trivial to identify the words in a hashtag, right? In a language like Chinese, there's no white space separating the words. In a language like Thai, there's white space separating the words some of the time. Sometimes white space means this is a new sentence. Sometimes there's no white space. So there's a whole set of problems there. But also, there's more to language than just words in a row, right? The words have relationships to each other. And a lot of what computational linguistics can offer is techniques for pulling out those relationships so that you can then do the deep learning or whatever machine learning you're doing over those linguistic structures instead of just what's called a bag of words. Does that make any sense at all? I think I went really technical.
Yeah, no, that made clear to me. It was total sense to me because I didn't know that Thai did the spaces represented different things. So yeah, that was new for me.
It makes a lot of sense, but those I think that's the purpose of computational linguistics is, for me listening to it is just, it's how to make the language cohesive. I know we hire a lot of contractors and language is a barrier, and how they translate the English, the communication is jumbled because, words that we think are rude are not rude for them. And we're just like, okay, the tone of our conversation has got me a little bit on edge. But then, you tell them that and they're like, oh, I apologize. So sorry. So those little nuances are very, very important.
And those nuances are part of why you don't want to just trust machine translation, for example. Right?
Yes. Yes, I wouldn't want a machine to translate all that stuff for me. I don't even like what it sounds like when when you have to you can do your voice to text on my phone, and things that I say or the dialect that I'm saying, I'm just like, okay, I'm going to get in a wreck. This is not helping me at all because first of all, I don't know how to use it correctly. And then if you stop and you're repeating things, it's just picking up stuff that you repeat, or it's picking up maybe a song on the radio. And so it's just like, okay, I'll just wait.
Yeah, and you bring up actually a lot of the issues with what's called automatic speech recognition, or ASR. So it works pretty well if you're talking about a variety of English that's very close to what newscasters speak. You're talking about a quiet room. You're talking about one speaker, right? If you move away from that, if you move to a different dialect or language variety, if you have other sources of noise in the room, if you have multiple different speakers, even if they're not talking over each other, but they speak a little bit differently from each other, all of these things make it harder, and what's called the word error rate goes up, right? And you also bring up the interesting point that there are applications where mostly right is good enough, and there are applications where if you make a mistake, it can be fatal, or if it gets a little bit too frustrating, then it becomes unusable. And so one of the key things in successful natural language processing and speech recognition technology these days is to find an application that has basically an error tolerance that matches how well your system's working. And there's interesting effects too. When people get frustrated talking to a computer, they change the way they speak. And like, when you're angry, that changes the way you talk. You might sort of hyper articulate, that is, exaggerate the sounds. And that might work well if you're talking to a person in a noisy environment, but it does not help the computer because the computer's been trained on a bunch of normally spoken language and not sort of angrily spoken language.
So that's like when you're like calling the bank and they're like, say one, and you're like one, and they're like, we didn't get that. And so you just escalate, and you're just like, can I get an operator?
Yeah, exactly.
And they're like, no, you need to press one. And you're like, okay, I can't. Yeah.
So here's an example of that goes the other way around. I spent some time on sabbatical living in Denmark a couple years ago, and we were making heavy use of Google Maps to help us get around. All right. And so Google Maps does text to speech too, right? It tries to pronounce the names of the streets, and that can be really hilariously wrong. And in the case of Danish, the Danish letter to sound correspondence is very different than it is in English, but Google Maps was pretending it was English. Okay. And for me as a linguist, this was frustrating because I was like trying to learn this language, and here I'm getting all this really bad input. And so I was complaining to my husband, who incidentally works for Google, but not on Google Maps and not on text to speech. And he was insisting that's actually a feature and not a bug, because if they had been pronouncing the street names in Danish, he would have no hope of recognizing the thing written there based on the sound. But since they were saying it in English, he got it.
That's funny. But it's so true, because how we pronounce it's totally different, and you don't mean to murder it, but you just don't know phonetically what it is.
Exactly. And so a computer that's using rules that approximate what we do as English speakers is gonna butcher it, right? Yes. But in that case, the error was actually helpful.
That's crazy. I mean, and I can I just imagine just like say me and Tamika are in the same room and we're both on our cell phones. Like, I usually hang up because you're competing, you unconsciously, you start to escalate your voice to hear your conversation, and it kind of gets loud. So two people are having a loud conversation with people over the phone that you can barely hear. So a machine trying to interpret all of the noise
Yeah.
I can only imagine how you separate all of that out, filter rather all of that out.
Exactly. And the machine doesn't have the advantage of other senses to apply, right? So if we're in a room with a bunch of people talking, we could use our eyes and do a little bit of lip reading or at least see who's talking, right?
Right.
And the machine just has a sound wave. It's much, much harder.
Next time a machine is going to be like, I tap out, like I'm over it. And then you're like, what? Wait a minute.
Yeah.
You what?
That's another really important point. You are hitting all of the really key points here. Another piece of this is the machines need to know how likely they are to be wrong, right? Sometimes it's better to say, I actually don't know if I've got this right, so I'm not going to give an answer, than, well, here's what I think it is. And again, that depends a lot on the application and sort of estimating that, figuring out, okay, what do I think the answer is and how confident am I? And where do I put the threshold where I say, yeah, no, not quite sure? That's a tricky thing that needs to be tuned sort of for each application separately.
It does, but it always is just like, can you repeat? We don't understand. Can you repeat? And you're just like, I'm over it.
Yeah, and those things are trained on, built for, one or two particular varieties of English, and do not respect the diversity of the way people speak. There's a real problem there because there's a lot of language varieties in this country, and the ones that get sort of handled first are the prestige ones, the ones that correlate with privilege, and the ones that are therefore most convenient for the most privileged people.
Yeah, I get it all the time. There's just certain words, and me and Tamika, we laugh about it all the time because she's from Georgia, I'm from California, and just words we say are different. And then, like, I had a client today, and I said, feel. And he's like, who is Phil? And I'm like, Phil, like F-I. He's like, oh, Phil, F-I-L-L. And I'm just like, yeah, buddy. And it's just like, we're all speaking English, aren't we? But we're really not. Phonetically, what we hear and how we enunciate our words and what's spoken in our home is totally different. And so we laugh about it all the time. And when she impersonates me and vice versa, we just crack each other up. Because I'm like, really? Do I say that? And she's like, yeah, you're a singer. Like, you're going to sing all the words.
like you're doing now.
Yeah. He's like, sing all your words. I'm like, why? No, I don't. She's like, yeah, you do.
Yeah, I call her the singer. Diana Ross in the making here. Yeah, she sings all the words.
And then when she was around my family, she was like, oh my God, it's just California. You guys are just so proper. Yeah. And I'm just like, I know your mom. Like, I know your mother. Stop it. It's not just California.
My mom is very proper. My mom is an English teacher, so, you have to say and enunciate everything. But we're Southern, so there's that Southern drawl to it as well. But, she made it a point to make sure you knew how to speak, open your mouth, and say your words. Don't mumble. That type of teaching. And of course, as a kid, you're gonna resist. You're like, I'm just gonna mumble all this stuff. I don't want to do all that. I'm lazy. So it's one of those things. But in retrospect, it's funny because I've been away from the area for so long. When I go back and talk to people, they're like, "Well, you're not from here," and I can hear certain things that I say or even how I talk. I'm like, no, I'm still from here, and they're like, no, you sound like they're like they say you sound like you from New York or you may be from California or something like that. And I'm like, well, I can give them probably a West Coast thing because I spent 5 years on the West Coast, and that's probably the longest place I ever lived outside of here. Like today, the 17th made 5 years here, so they're equal. So it's almost time for me to move. So you may be getting called for a reference.
Well, happily, as always.
So it's almost that time. So in all, I know you said there's some you guys switch from the was it CMLA to CM? No, was it? Hold on,
CLMA. Yeah, and now it's CLMS.
And that's just a full year. That's a full intense year.
Right. If you do it in 1 year, it is super intense, and we tell people don't plan on doing anything else during that year. Like, don't, you're not going to be working. Don't start a family.
Don't breathe. Don't go on any radical diets. Or take up.
Do take care of yourself. Yeah, do get sleep, do get exercise, but basically eat, sleep, exercise, study is the 1 year schedule, and you can spread it out. And exactly how intense it is depends somewhat on just how facile you are with debugging, right? Because as you two know, debugging can be a complete black hole with time, right?
Right. Resources and time, memory and time. Oh, the machine went down. Can you kill my process? Sure.
So, but yeah, so it can be done in 1 year, but it can, many people spread it out over 2 or 3.
So I know you talked about conferences, and I know you go to a lot of conferences.
Mm-hmm.
Do you ever take, it's probably a 3-part question here, do you ever take any of your students to the conferences? And if you do go to those conferences, what conferences do you normally go to? Are they stateside conferences, or are they overseas?
So both, and I particularly enjoy the overseas ones. And yes, we do bring students. So there's one sort of in-group conference that I go to, which is called Delphin, and that one is sort of an internal working meeting of an international collaboration that I belong to, and so I try to get my students to that every year if I can scrape together the funding. And then otherwise, if we have a paper, either the students by themselves or together with me, then we can usually find funding to send the students to go to whatever kind of conference. And the major conferences in the field are ACL, which is the Association for Computational Linguistics. There's NAACL, NAACL, that's a North American chapter of the Association for Computational Linguistics. And I'm actually the chair of the Executive Board of that organization right now, which is kind of exciting. There's the European chapter.
Go, girl.
So parallel to NAACL, there's EACL, which is the European chapter, and then in Asia, there's something called the organization is called AFNLP, the Asian Federation for Natural Language Processing, and the conference is IJCNLP, the International Joint Conference in Natural Language Processing. And then there's some other ones, CoLing, which is going to be in Japan this year, which is Computational Linguistics Next CoLing. That one's been going for a long, long time.
Yeah, I remember that one.
Remember that one? Yeah. LREC, Language Resources and Evaluation Conference, and that one tends to be around the perimeter of Europe. So I've been to it in Reykjavik, Iceland, and I've been to it in Malta. This year it is, I think, in Slovenia or somewhere thereabouts. It's it doesn't go sort of right in the middle of Europe, but kind of around the edges. And I think those are the big ones. EMNLP, Empirical Methods in Natural Language Processing. It's another one of these major conferences, and that one is in usually in the fall, and this year it's going to be in Austin, Texas. And it was in Seattle a couple of years back. It's also international, just those are the ones that I remember, and they're stateside.
That's a lot of conferences.
Yeah, and good to know, especially for anybody thinking about getting into this field, all of those conferences publish their proceedings online in open access. So anybody can get to it on the web. The thing to search for is ACL Anthology, and you get to this website that has the publications from all of these conferences and a whole bunch of workshops affiliated with the conferences going back decades, all freely available online.
Cool resources.
I'm sure we're going to have to play this back and pull out all the websites and names and acronyms.
Yeah, I did. And I'm usually like a rapid note taker, but I was just like, I'm transcribing this thing because it is some awesome information and I want to pay attention.
Excellent. And I talk really fast, so I'm sorry for that.
But you were very clear. Like, it was very, I was like, we can just let her go on coast. I was like, this is the best first interview ever. Emily, come back anytime.
I'd be happy to.
I just think you are my first my first interviewee for Women in Linux, but it is more about like the different fields that and the different exposure for women to get into that go down the path of computer science and then they don't know what to do. Like I don't know what I can do. Like, oh, I've never heard of that. But it gives you the opportunity to see what you can do in the field while you're there. And I encourage a lot of women to go just sit in a class sometime because you just never know what you could be interested in and you just even know it existed. So sometimes you just have to go sit in a class.
And I love having opportunities like this. Yeah.
Yeah, what you did, and you found your calling. Exactly. Like, goodness, it's great.
Yeah. And linguistics and computational linguistics are not well-known fields. I mean, we're about to do our admissions for this year, and I have 121 applications to read through. And we're going to have a new cohort of about 30 students. We'll probably offer acceptance to about 40. And if it's this year's like previous years, I'm going to find a bunch of those application essays are saying things like, I've always liked computers and I've always liked languages, and I had no idea there was a field that was basically the two of them together. And then I discovered this program. Like that's sort of the most common narrative in our application essays.
It sounds like you're doing your probability and statistics on your applications there.
Yeah. Exactly. Oh, here's the other thing. In case people are thinking about applying, everybody says that language is fascinating in these essays. And that's true. I agree it's fascinating, but it's not a good thing to put in your application essay because it does not distinguish you. And this is, all linguistics departments have this complaint. Everyone's talking about how they've always been fascinated by language. And apparently the analogous thing in computer science departments is everyone talks about how they love to play with Legos as a kid.
That's nice.
Yeah, I think I had a set and I passed it down to all my siblings. And I think my mom was like still vacuuming up Lego parts for my little brother. He probably had like scraps, but I think we all played with Legos.
Yeah, it's a great toy and it's relevant to computer science. Like I can see why people talk about it. It's just not helpful to put in your application because everybody says it. Right?
Wow.
So key word. No.
Yeah.
No Legos, not fascinated.
Yeah.
I think they might be looking at the same resources when it comes down to filling out those essays. Like somebody must have said, mention Legos.
And then admissions committees all across the country are like, oh, enough with the Lego already.
No, what they need to say is just like, I'm ready to give up my life for a year and commit to the struggle.
Yeah, it is intense, but you come out the other end with some real skills. And for people who are who like computers, like working with computers, and are interested in language, it's really exciting, interesting stuff to be involved in. And at the University of Washington now, we have a huge community working in computational linguistics and natural language processing, not just linguistics, but computer science, analytical engineering, and the med school, and the information school. And so it's a really exciting place to be right now.
This is the last and final one. As far as your architecture, I know, I came in and we had Pongo for the cluster, and I think you guys have moved over to Condor now. Is that still what you're using?
We are. So Condor is the main thing that we use for the high-performance computing jobs. And I took your advice and asked the current sysadmin for the details ahead of time. So I'm reading off of something here. But so Condor is the main thing. We also have Hadoop and Apache Spark installed. And he says he uses Puppet for configuration management behind the scenes. And our current OS is CentOS 6, but we're moving to CentOS 7.
Ooh, good luck. It's a big architecture change, but I don't think you guys would see it. I think he's probably going to see it more than what you guys see.
Yeah, it's these problems. And the cluster's a lot bigger than when you were here. We've been sort of growing it year by year to make sure we stay at, like a step ahead of the computing needs of the students. So we've got 11 systems are the compute nodes, and together they have 124 cores and 864 gigabytes of RAM. And one 11 terabyte file server for the sort of shared data. We talk about corpora, which is large text collections. and then another 8 terabyte server for the home directories.
That makes sense. All of that makes sense to me.
Good. It's got to make us think of approval.
I know, right? Oh, that makes sense to me. Our listeners, we want it to make sense to you too, but you can totally geek out with us all the time. Here,
so that makes total sense to me. So yeah, I can see why you guys would be in Hadoop and then using that and batch processing on top of all of that and Spark and so forth. So yeah, all that makes sense to me. Yeah. And I'm glad you guys got an upgrade and actually got in the Colo. Over there. I mean, I know it's an ongoing battle because they didn't want to support that for a while. So I'm glad to see that you guys actually got a chance to get out of the little room.
Yeah, that room was a disaster. The other thing we've done, I think this is since your time, we used to have one head node, and now we have 2. So if one of them is down, people can use the other one, and it makes the whole thing much more robust.
Right. Yeah, the other way it was, you had another head node, but it wasn't automated. So that's what the next thing was, is having it automated. That was the next step.
And we don't call anything Pongo anymore. We still have all the nodes are named after species of primates, and so the head nodes are Patus and Dryas, and some of the sort of web-facing things are Vervet and Wakari. Can't remember all of them. And the joke here is that speaking in terms of probabilistic natural language processing, 1 million monkeys typing for 1 million years would eventually produce the works of Shakespeare, right? That's where the primate name.
I get it.
We have a physical space that the students can hang out in that's got just like, I think, 3 workstations now because everyone's bringing in their own laptops and then connecting to the server cluster. And we wanted to call that place the Primate House because of these primate names. And in an old building, it was sort of right next to, it shared a door with some space that belonged to the Spanish and Portuguese department. And the chair of that department said, no, you can't put Primate House on the door here because Peter's going to come and firebomb us. So instead, we call it the tree house, and that's where monkeys live in trees, but also tree structures are really important in linguistics and computational linguistics. So our lab is called the tree house.
I get it. That makes sense.
Now, before you let you go, is your program on social media? Are there any social media that our listeners can follow? Can you leave it with us?
Yeah, absolutely. We have not gotten onto Twitter, though I'm personally on Twitter at Emily M. Bender. And the program is on Facebook. If you search for UW CLMS, I think you turn us, or UW Computational Linguistics, you can turn us up on Facebook. We have about 4,000 followers on Facebook, and I'm always happy to have more. And I like to post things there about linguistics, computational linguistics, AI that I think would be fun for people who might be interested in our program.
Cool beans. Thank you so much for your time and your information. You are awesome. And I look forward to chatting with you again soon.
Yes, let's do it again. Very good to chat with you guys.
Thank you for tuning in to the Women in Linux podcast. Women in Linux is a 501c3 not-for-profit organization created to get women involved in the field of IT using Linux as a foundation. You can connect with Women in Linux through social media at Women in Linux on Twitter, Facebook, LinkedIn, and Instagram. To join weekly meetups, go to meetups.com/Women in Linux. For more information and to connect with Women in Linux, go to www.womeninlinux.com.